Now let us consider this figure for the torque on the current loop. Here you can see a rectangular loop, and the smaller sides are indicated by side 1 and 3. This is the first length segment. This one is the side 2, the second length segment, side 3, the third length segment, and side 4, the fourth length segment. Now the shortest sides have a length A, and the longer sides are having a length B. Next, this rectangular loop is carrying a current in this direction, which is the clockwise direction. It is placed in a uniform magnetic field B, which is indicated by these parallel lines, and you can see that the spacing is equal, so it means that the field is uniform. This is the y-axis, this one is the vertical axis, is the z-axis, and this is the x-axis. This unit normal n is determined by the right hand rule. You will curl the fingers of your right hand in the direction of the current flow, so the stretched thumb will give you the direction of this unit normal n, which is the normal to the plane of this loop, Now the plane of this loop is vertical, and this is the unit normal n, which is the outward drawn normal to the right face. This is the left face facing towards this side, and that face which is facing towards the right is the right face, and this is the normal n to that right face, outward drawn normal, which is determined by the right hand rule. Okay, so since this is the normal to the plane of the loop on the right side, so this normal must be perpendicular to each and every length segment as well. This is the point which must be kept in mind. So let us now calculate the torque acting on this current loop. So for that purpose, we will consider the force acting on each and every segment. So let's consider the force on this side, which is the longer side and which is having the length B. So the force on this side is given by the formula. Since this is the side 2, so we will indicate it by, let's say, F2, and this F2 will be equal to I into L into P into sine of the angle, which is theta, between the two. Let it be theta, that is the angle between L and B for this side. Now look, I is the current carried by this line segment, and L is the length of this line segment, so this will be denoted by B. So let us write it again. This F2 will be equal to I, which is the current, and the small b, which is the length of this side, into the capital B, into the sine of the angle between the two. Now let it be the angle theta, which is the angle between what? you must keep it in mind. This is the angle between the side B and B. So what is the angle actually between B and small b and capital B? Now let us look at this. The unit normal n to this face is also the normal to this side as well. This is the direction of the unit normal n, and since it is normal to this side, so it means that this whole angle, okay, this angle is 90. Okay, let me make it clear. Now what is this? This is the angle between the unit normal n and the side B. This is 90-degree angle. And the angle between the unit normal n and B is theta. Okay, sorry, we will take this angle on this side because the current is flowing this way. The current is flowing this way, and the angle is always determined between the tails. Okay, so this angle is 90-degree between n and small b. This is small b, and this one is small n. So look, this is the length segment B, and this is the unit normal n. The angle is 90-degree. So the point which I want to make is we have to determine the angle between small b and capital B, and the angle between this capital B and unit normal n is theta. Okay, so this much angle is theta. The unit normal n, that is the angle between the unit normal n and B, capital B, is theta. This much is theta, and this whole is 90, and we have to determine the angle between capital B and small b, that is this angle. Okay, this whole angle is 90, this angle is theta. So what about this small angle? This would be equal to 90 minus theta. 90 minus this theta will give you this theta. Or this 90 angle is made up by this theta plus this angle, which is the angle between B and small b, capital B and small b. Since this product, we have to determine the force, and the force includes the angle theta. Actually, this is not the same angle theta as between this one and this one. We have to denote it by some different different letter. Let it be phi. Let this angle be phi, because theta is the angle between this B and the unit normal n. It is given by theta. So this angle between small b and capital B, small b and capital B cannot be equal to theta. It must be denoted by some different letter, and let that different letter be phi. Okay, so phi is equal to 90 minus theta. So the force